Yeah. Okay. So let's do this. Okay, I'll go ahead with step number 3. And if you have any problems or queries regarding step 1 and 2, let me know. Just stop me whenever and ask. Yeah. Now, what we did earlier was just a sec. Let me find out where that is. Yeah. I hope everyone can see the Visual Studio code, right?
Yeah, Saurabh.
Okay. Now what we did was we created a route handler called /hero and pointed to a different file called hero.router.js, right? Everyone knows how to create a router right now. So just import these two lines here, copy these two lines. OK, import express from express and then import the router class. And you just export that router class at the end, right? Between these 3 lines, you write all your route handlers. OK, all your get, put, post, delete, all your REST API, you write it here. OK, now what I've done is instead of hard coding my heroes, right, in a JavaScript array, I'm getting it directly from my database. Okay, and the way I've done that is I've created 2 files here. One is your hero model.js and one is your dbutils. Okay, let me walk you guys through hero model first. Now, uh, so right now we are doing this superhero thing. Later on, I'll explain how will you do something similar for any other business use case. Yeah. What I've done in hero model.js is I am trying to define the table structure. Since we are dealing with a relational database, we need to define a table structure. Yeah. And the way I'm doing that is using this create table function here. OK. So first of all, I've given a table name. This table name I will use in different places wherever I want to reference this heroes table, right? So instead of hard coding heroes everywhere, for example, I want to get all the heroes. So instead of hard coding heroes here, I could have easily done this. Yeah, heroes. OK, instead of doing that, I am just getting the table name into a local variable here, table name, and then I'm using that. OK, and this table name is coming from my hero model.js. Okay, so I imported hero model.js and I have kept it in a variable. In that variable, now I am able to access my table name. Okay, which is here. Yeah. Now again, I have done some sample data here just to pre-populate my table. Okay, I don't want to start with a blank table because then I'll have to create multiple records in that table. I'm starting with the sample data here. So this thing we did on, I think, uh, Tuesday. Yeah. So we started with a sample table here, sample data. These are all the rows in the table, right? With all the columns. The way I have defined my table is now this particular line, it says that I have an ID column, which is auto increment, meaning this ID table will start, or sorry, this ID column will start from 1. And as and when I'm adding more and more rows to this table, this will be automatically incremented by my database. OK, so I don't have to write any logic in JavaScript to handle this scenario. Okay, so auto incremented by starts from 1. Then I'm giving some more columns here: name, power, team, full name, weight. OK, this is how I'm defining my table structure here. Now, going inside dbutils here, what I've done is I think all of you should be now familiar with this syntax, right? So I'm using knex as my ORM. Yeah, and using knex, since knex can talk to various kinds of databases, right? It can talk to Oracle or SQLite or Postgres or MySQL or whatever. I'm saying that I want to talk to a SQLite DB. Okay, now SQLite DB deals with files is works with files. So I have also given a file name here, which is inside my current directory, db.sqlite, okay, which you will find it here. Okay, if this file is not there already, Next will create that file. If that file is already there, Next will simply use that file. Okay, now this piece of code here, the try block here. Okay, all of you guys know what try catch is, right? Or let me ask you this way. Is there anyone who doesn't know try catch? Because I can explain.
Yeah, sir. Can you explain it once?
Sure. So try catch is a way of dealing with exceptions. Okay, some runtime exceptions that might occur. So for example, let me say that you have a variable called a, okay, and you have a value called 9, for example, and you have a variable called b, and its value you are getting from user. Okay, so for example, let me put null for now, but get this value from user. Okay, so at runtime, somehow you are getting this value from the user. And what you are trying to return to the user is your variable c, which will be a divided by b. Okay, essentially you are doing a division operation and you are sending that result back to the user. Okay, so send c back to the user. Okay, now write this piece of code here. Okay, actually do this. Dot get divide req res. So now this syntax should be familiar to all of you, right? The way we are defining our get APIs, post APIs, right? Is there any question with this while I'm explaining try catch as well? Okay. Oh, cool. Now the way I am doing this is I'm saying I want to get a path parameter called b from my user. So I'll say let, okay, wait, I'll take a and b both. Okay. So let a equals req.params.a, let b equals req.params.b. So I've taken both the path parameters from my user. Now what I want to return to my user is rest.send result is, so I'll do this, let c equals a divided by b. Okay, result equals c. Now this is a very simple looking get API, right? Should work easily. Let me save it. And my server is running on it. Yeah. Now what I'll do is yeah. I'll say localhost 8888 and divide and put 9 as A and 3 as B. So the result is 3. So 9 divided by 3 is 3, correct? Any questions till now? All right. Now this is simple, right? But what if I, as a user, instead of saying 3, I say 0. Okay, result is now null. Yeah. So instead of doing that, I could simply put it within a try catch block. Okay. For example, I can do this.
Gaurav, could you please explain the functionality of let and const variables?
Sure. Okay, let me do that as well.
Oh, okay, Saurav.
Okay. So what I can do here is if I'm expecting some error coming up here. Okay. If I'm saying that I'm expecting some error, that error I can catch with try catch. Okay, so in the code, for example, here in DB utils, I'm expecting some errors. I'm expecting means there can be some errors at runtime, okay, which I'm not able to handle during writing my code. Okay, so maybe some error occurs. So let's say that you you had a db.sqlite. Okay, while running this line, you had your db.sqlite file, but while coming to this line, for example, yeah, somehow your db.sqlite file got deleted. So tomorrow, if and then I want to access my DB variable here, yeah, it will throw an error stating that the DB was not found, the file was not found. Okay, and there is no way I can foresee that during writing my code. So what I have done is I have kept all these lines inside a try catch block. What I'm doing is if something goes wrong here at runtime, some sort of error happens at runtime in these lines of code, whatever is in my try block. I want to catch that error or exception, right, in my catch block. So that exception variable is will be E here, or you can call it error, or you can call it exception, whatever. Okay, I'm just calling it E. Then I can handle it appropriately. Okay, for now I've just logged it in my console. What you can do is you can probably do some sort of exception handling. You can send result back to the user stating that something went wrong, please try again or something. So there should be a graceful handling of errors. Okay, in a good program, you should always anticipate your errors and there should be a graceful handling of errors. So that you might have seen some cases where you are seeing 500 internal server errors. Some technical jargons are thrown at the users, right? You go to a web page and they say the site is down and sorry, not sorry, they show some very technical looking errors, error ID and whatnot. Okay, which doesn't look good at all. Okay, what we can do is we catch errors properly and then we respond appropriately to the end user so that they are not shocked when they see an error message. Okay, I think I have an example somewhere. Let me just give an example to you guys of a good looking error. Da, da, uh, I think this is the one. See, so this website, I was going through this website some time back, and accidentally stumbled upon a link which was not working on their website. Okay, so see this, the way they have handled this. Okay, normally what I can do is if I'm hitting a URL which is not existent, okay, or I am getting a 501.500 some server side error that occurred, right? So I would see very cryptic looking, very technical looking error message. But instead, what this website has done is they have created a very beautiful looking page for that. Okay, so this now there are a couple of things happening here. First, the user is not taken aback. Okay, they are not seeing anything technical which they can't understand. Okay, they have written some good looking message. The page went missing. That can only mean one thing. So they are being funny here. Okay, and then they have given some links also back to their website. Okay, so this is called graceful error handling, and this you can use with your try catch blocks. Okay, wherever you find some error, you handle it properly, appropriately. Yeah. Okay. To your let and const thing. There are two things we have: let and const. Okay, and actually we have three things in JavaScript. We have a var, let's say f. We have a let, let's say g. Then we have a const, let's say h. The difference between var, let, and const, and these are the three ways you define your variables. Okay, why is it saying something? Const shape, correct. Okay, I'll come to that. Now, traditionally, the way JavaScript had worked was that there was no block scope. Okay, when I say block scope, if you are from a Java background or from a C, C++ or a C# background, you know what a block scope is. Okay, so if I say if true, for example, this is some condition, and I define a variable here, ABC equals zeros, and I just do some operations on this ABC and do something. Okay. Now, since I am declaring my variable with var here, okay, this block, this curly brackets block here, okay, will not be the scope of this variable. Okay, so the variables declared with var, they have a function scope, not a block scope. When I say function scope means the whatever is the enclosing function. Okay, so for this variable, the enclosing function is this function. Okay, so this is an arrow function. I could have easily written it like this. Function, I could have written it like this. Now you will see that there is a function here. Yeah. So for var variables, the scope is your function scope. Whatever is the uh, innermost enclosing function, that will be the scope. So the only difference here is scope. From var and let different scope. Scope is the innermost enclosing function. Okay, while let, if I do let here, okay, instead of where I can do let. Now let has a block scope. Wherever you see the curly brackets, that becomes one block. Okay. Now traditionally we have always dealt with block scopes. Okay, JavaScript was the first language or first programming language that introduced functional scope, and which was very confusing for everyone. Okay, and it became a source of great many errors, because what our human mind will think that since I am enclosing my variable within a block, that variable should only be existing within that block. But no, that's not the case. Okay, there is one more way you are doing. You can, so I cannot show it here because this is in a module and it will not allow me. What I can do is I can simply in JavaScript, if I don't typically if you are working in a browser environment, right? If you don't declare a variable using var, let or const, if you just simply create a variable and use it, right? That becomes global scope. Okay, and that is a very bad thing to do. Okay, if you are doing some kind of programming some 10-12 years back, then most of our programs work like that. Okay, we never bothered to declare our variables. We will simply write our variables, use it, and which is a very bad thing to do. Okay, so always declare your variables, and starting from I think 2016 or 2017 actually, yes 6, we have let now. Let gives us block scope. Okay, so I'll write it here. Scope is the block, meaning curly brackets. Whatever is within the curly brackets is your block, and this variable, any variable declared with let, right, will be only visible or will only work within the block it is declared in. So for this let ABC will work only within this block. Okay, so that's the difference between var and let. Now const. Const, like the name suggests, is a constant. Means if you define a constant somewhere, you cannot change its value later on. Okay, so that's why there is a red color line. It says const values should also always be initialized, meaning since you are never going to be able to change it later on, right? If you don't provide a value right now while declaring this variable, you will never be able to assign anything to it later on. So that's why this is giving an error stating that please assign something here. So I just assigned a blank string. It is happy now. Okay, but later on I cannot say h equals ABC. Okay, now there are some if you are using TypeScript, for example, later on, this will definitely show an error in your Visual Studio Code. Now it is okay, but if I run this at runtime, this will fail because const variables cannot be reassigned. Okay, so declares a constant variable. It cannot be reassigned later on. Okay, now Normally a question comes to me, then why will I use const anywhere? I can simply work with let, right? Why should I assign const now? So the technical difference between const and let beyond this is const variables use lesser amount of memory. Const variables use lesser amount of compute time because the compiler doesn't have to worry about reassignment later on. Compiler doesn't have to worry about what happens if the value changes later on, right? It can simply say, okay, I have this value, which is a const. I will simply give it the uh, memory it requires at initialization, and I know this cannot be changed, so I'm happy. Okay, so that's why const variables will always occupy lesser amount of memory and they will use lesser amount of compute time as compared to let variables. Okay, so if in your applications, if you see that there are times where you can define const variables, always do that. If you see a variable which is not going to change in your program, please use const instead of let, and never use var. Okay, wherever you are used to use var, please go ahead and use let. Okay, all the browsers, Node.js, all the JavaScript runtime environments, wherever we are using JavaScript nowadays, they honor let. They know what let is, they work with that. Okay, all the browsers right now. Okay, unless you are running Internet Explorer 6, which is a very bad thing to do anyways. I hope no one is using Internet Explorer 6. Okay, any questions on try, catch, let, where, const?
What is the scope of const, which is global scope?
No, sorry. Const is also like let, it is block scope.
Yeah, okay.
So the only difference between let and const is that const is a constant variable. You can't change its value later on. Rest everything is let.
The keyword avoid, what does it mean? What it will do?
Which keyword? Sorry.
The keyword avoid.
Wait. Okay. Let me show something. I should have something here. No, not here. Here. Wait, just a second. Save some files. I've written some. Yeah. Okay. Now I'll talk about await. Okay. So. Yeah. Await is a part of two word. There are two words, keywords, async and await. Yeah. Now async and await are part of asynchronous programming. Okay. When I say asynchronous programming, like we discussed when we were doing asynchronous programming thing, right? So you are expecting some value. Let me open that for you actually. Wait. Just a sec. What's here? Yeah. Okay. Now, when we spoke about asynchronous programming, right? So I said you can do asynchronous programming in three ways in JavaScript. One is using callbacks. Okay. Any doubts about callbacks? All right. Then the other way was promises. Okay, this was a newer syntax from the JavaScript specification, which lets us use promises. Okay. Any questions about promises before I go to async commit?
Can you just give an overview?
Sorry?
Explain those two promises once again.
Callback and promises.
Just yes, yes,
Okay,
yes.
cool. Yeah, sure. Now, the way callback works is think about this. Okay. So far, whatever routers we are writing here, or even the listen. Let me show you the listen one. Okay, so consider this. What I'm saying is app.listen, and I'm giving it a port. Okay, and then I'm passing it a function here. Okay, so this itself is a function. What I can do actually is function after listen. Okay, log. Something was changed. Anyways, now my server is listening. Okay, what I can do is instead of doing this, I can simply say after listen. What I'm doing is I'm passing a callback function. Callback means once something happens, okay, once anything that happens, I'm saying, okay, once my app starts listening, call this function. Okay, very similar to, for example, you get a call on your mobile phone, you are not available, right? And you call that person back. Okay, so once you are done with whatever you are doing busy with, right? And then you call that person back, right? Something very similar here. So once JavaScript is done doing something, in this case, when JavaScript is done listening to your application or starts listening to your application, it will call this particular function. Okay, so this is the way of doing asynchronous programming. So you are not waiting around for this thing to complete. Okay, you are not waiting around. You are not blocking your operations just to listen. You are simply stating to JavaScript. You are just saying to JavaScript that okay, once my app starts listening, call this function so that I know that this thing is done. Okay. Similarly, here in the example that we took last time, we are saying that there is one function called set timeout in JavaScript. It lets you run a piece of code after certain milliseconds here. Okay, so for example, let me pull this one out. So if I call this function callback, okay, so this is the function definition. This is how we define a function, and this is how we call that function. Yeah, this is simple, right? Everyone knows this. So as soon as I call this function callback, what will happen is JavaScript will see this statement set timeout. It will know, okay, I have to run a certain function which is defined here. Okay, I have to run this certain function after a certain period of time. That period of time is given to me here. These are 2000 milliseconds. Okay, 2000 milliseconds. Okay, so after 2000 milliseconds, this function will be called. So this is an example of a callback. Okay, this blue code. Okay, or I can actually write this also. This is also okay. So this blue function here will be called back after 2000 milliseconds. Okay, similarly, your after listen function here will be called back once your app starts listening. Okay, similarly, if I show you this, right? So we just now created a get API called divide. So this function here will be called back once a user hits this particular REST API. Okay, so that's the concept of callback. You call a certain function once something is done. Okay, that thing can be anything. A user calling an API or set timeout. Okay, or you getting your data from database. Let me show you. Okay, getting your data from database, anything. Okay, that can be anything. Now, callbacks are one way of doing things, and we used it very frequently in our programming many years ago. Okay, it was very useful, and we still use it somewhere. Okay, like I showed you in Express, we are using it. But if, like in this example, I have one set timeout inside another set timeout, right? Now consider right now I have only two, but consider what if I had 10 like this, one inside the other. Okay, it will become very, very hard for me to understand what is going on. Okay, very, very hard. this. Can anyone really follow what is happening here? No, right? Can anyone really follow this, guys?
No, sir.
No, it becomes very, very messy, right? Unmanageable. Now, this particular thing that you're seeing a cone-like shape here, right? This is called a callback hell. Okay, if you go and Google callback hell, you'll know what I'm saying. Okay, so let me show you. Callback hell. See, they have a page for callback hell, like something like this. Yeah, a cone-shaped code. Okay. Now, instead of using callbacks now, we have something called promises. Okay, promises are now the standard way of dealing with asynchronous programming. Again, we are doing the same thing. We are not doing anything out of the blue. Yeah, what we are saying here is that I am trying to fetch some data from this particular URL. Okay, and the whole concept of asynchronous programming is that we are expecting something to happen, but we are not sure when that thing will happen. Okay, so once that thing happens, we want to run a piece of code. That is what asynchronous programming is all about. Okay, whether be it callbacks, be it promises, be it async await. Yeah. So what I am doing here is I am fetching some information from this particular URL. I am putting it inside a variable. The variable I have called it fetch promise. I can really call it anything. Okay, doesn't matter. Okay, what fetch returns to me is a promise. Okay, so the good thing about Visual Studio Code, guys, is that if you're using standard APIs, standard JavaScript APIs, or any APIs from any package which you have included in your package.json, if you hover upon that, you will see this kind of an information. OK, so it says the fetch function. The signature of this fetch function is the fetch is the name of the function, and you pass it some URL or request info, some parameters, and after colon, you see this colon, whatever you see after this colon is the return, what this particular function will return. So this function is returning to me a promise of a response. OK, now it is not returning me the response directly. It is returning to me a promise of response. OK, this is how we write it. OK, any doubts with this concept, the return type here? Like I said, it's not returning the response. It is returning the promise of a response.
What is the difference of it?
OK, so the difference. Now, like I said, I really don't know when this data will be fetched. OK, for example, I am on a very slow network. Yeah, so typically, if I am on a fast network, it might take me, let's say, on a fast network. OK, on a fast network, it takes me some 1 second to fetch data from this particular endpoint. But on a slow network, it takes me, let's say, 5 seconds, right? Now, I'm not sure while I'm writing this code, how much time will it take, correct? So fetch function here is giving me a promise that, OK, at least I promise you this. The fetch function says to you, I promise you this, I will give you a response, although I don't know when. OK, so that's why fetch function gives you a promise or promises you to give you a response, but without committing to a timeline, without saying when. OK, that's the whole concept of asynchronous programming. Like I said, we want something to happen, but we don't know when it will happen. OK, I know this is a bit of a tricky concept to grasp. OK, asynchronous programming. That's why asynchronous programming is tricky, because you have to wrap your mind around that I will get something done. I don't know when. OK, that's why we use async await, which is again asynchronous programming, but in a synchronous manner. OK, I'll come to async await also after this. So just for now, just consider that fetch is giving you a promise or is promising you to give you a response at some point in time. OK. So rename this again. Yeah. Now the promise itself is now in a variable called fetch promise. The way to deal with promises is you write a promise, then you write then. OK, so on a promise, you can have two sort of functions here, then and catch. OK, now a promise can result in multiple ways or can be terminated in multiple ways, but two of the most used ways is then and catch. OK, then basically means that you got some response. You got some response. OK, so whatever you were expecting happened. Doesn't matter when it happened, but it happened. Catch will basically mean something went wrong. OK, so in a promise, you put then and catch. Always you put then and catch. Since when you are writing a program, you don't know whether this program will work or not. Or for example, if you are fetching this data from this URL, right? If the URL exists, then you will fetch that data, you will get that data, you will go in then. But somehow if the server is down, if for example mdn.github.io is down, right? So you will not be able to fetch that data. In that case, the control instead of going to then, it will go to catch. Okay, like I said, error handling is a very important part of developing applications. So we want to catch all our errors proactively so that we can handle those appropriately. OK. Any questions, guys? I'll explain more about then and catch, but before that, any questions?
You said no, asynchronous program. In what cases we use asynchronous program? I know it doesn't depends upon the completion of an object, but yeah, can you give a brief example of asynchronous?
Of what? Async await or asynchronous?
Async and synchronous both.
OK, yeah. So, so asynchronous programming, the example of asynchronous programming. OK, yeah, sure. So let me give you guys this example. So I can give you three examples. OK. One is your wait, yeah. One is your user event. User event means you need user to do something. Okay, for example, you are creating a UI5 application, and in that application you have a button which you want the user to click. Yeah. Now user has opened your application and you want that user to click that button, but you do not know when the user will click that button. Correct? You just presented that user with a button, but you really not know when user will click that button. Is that understood, everyone?
Yeah, sir.
OK,
Yes,
so
sir.
that is an example of asynchronous programming, meaning you want something to happen, but you don't know when it will happen. User can click it in 5 seconds, 10 seconds, today, tomorrow, doesn't matter. User is user, he can do whatever he wants. Right? So waiting on user to perform certain action. This is an example of a asynchronous programming. Then another is fetching, or no, not fetching, calling an API, REST API, for example. OK, like we are seeing in this example, this one is a REST API. OK, let me show it to you. Okay, now this REST API gives me a JSON of products. Okay, now since I'm on a decent enough network, as soon as I hit enter, it gives me the result. But consider uh, if you guys had internet some 20 years ago, we used to work on dial-up modems. Okay, so 56 kilobytes per second, 56 kbps second, your dial-up modems. Okay, those were very slow, really very slow. Okay, so if I did this thing on a slow network, it would take ages. Okay, right now it's very easy, but at that point in time, it would have taken me at least 5 to 10 seconds just to load this much data. Okay, now that again is an example of asynchronous programming. You are hitting an API and you are expecting some response back from that API. So you don't know how much time will it take. Let me show you here. Okay, this will make good sense. Now what I've done is I have opened the developer console here. Okay, there are multiple ways of doing that. First is you right click on your browser, Chrome or Edge somewhere, and you click on inspect. Okay, you get this, or you do Control Shift I. The same thing will happen. Or I think, yeah. Am I back, guys? Sorry, I accidentally turned on my airplane mode. Can anyone hear me?
Yeah, sorry, you're audible.
Oh, I'm sorry for that.
Yes.
So the third way of doing this is F12. You press F12 on your keyboard, you'll again see the same thing. Okay, so 3 ways of opening your developer tools. Now let me refresh it. Okay, see this. So this API got hit. The total size of data that was given back to us was 235 bytes, and it took 144 milliseconds. Okay, I think I don't see that option, but there was an option here to slow 3G. Now I'm on a slow 3G. Let's see what happens. See, so I'm basically mimicking a slow network now. Yeah, from my developer tools here, I can do that. So earlier it took me some milliseconds. Now it took me 2 seconds on a 3G network. It is trying to mimic how much time it will take on a slow 3G network, right? So now it is taking me 2 seconds. This itself is an example of asynchronous programming. So you want to get some data from an API, but you don't know when it will happen. That depends on user's network, right?
So
But you want,
this comes under promising, you know.
sorry.
So this comes under promising function.
So this you can handle this thing via callbacks or promises or async await. Okay, so asynchronous programming in JavaScript can be done in 3 ways: callbacks, promises, and async await. Right now, I'm showing you the example of what is asynchronous programming. You can handle it in multiple ways. So another example is calling a REST API. So waiting on the response from a REST API. Third example is, for example, your getting data from DB. Okay, like we will see it in our program. Here I'm getting I'm getting data from my table and I'm using await here. Okay, since again a database operation is an async operation, meaning we want some data from database, but we don't know how much time will it take. Right now, for example, I had only 6 rows. It was pretty fast. Okay, but consider if I had some tens of millions of rows, right? So getting all that data from database will definitely take time, right? But we don't know how much time. So in those, that is also an example of async programming. So waiting on the data from a database. is also an example of async programming. Now you can, like I said, you can handle this in three ways: callbacks, promises, and async await. Okay, so we spoke about callbacks, which is something which you should not use unless you absolutely have to. Promises you can use, but talking about promises, you can still see something similar happening here. Okay, for example, I have this promise, and then after I get some response from this promise, I want to call some other API. Okay. Then after that, I want to call some other API. And after that, I want to call some other API. Yeah. Now see something similar happening like callbacks, right? This is also a sort of a callback hell, right? One promise inside another, inside another, inside another. That also creates a mess in my program. Okay. Instead of this, what JavaScript gave us now is async await. See this. Show you. Yeah. Now, fetching data from this API, and you are using promise in this example. So you had to write all these lines of code for doing this. OK, now using async await, what you can do the same thing, exactly the same thing, just by writing 3 lines of code. And it becomes very, very easy to understand. OK, you know this line will happen first. Only when this line happens, this line will happen. And only when this line number 72 happens, will this line run. Okay. So technically speaking, async await also use promises behind the scenes. Okay, but you as a developer are not worried about that. You simply say, OK, I am using an asynchronous API here or an asynchronous function which returns promise to me. So whatever function returns a promise, you can put await before that. And as soon as you put await here, you get the data directly. OK, so as soon as you put await, now the return is not your promise. Now the return type will be your response. OK, since you are simply saying that whatever promise this fetch gave you, wait for that promise to be fulfilled and then only pass the data into my data variable. Similarly, whatever promise this data.json promised me, only after that is completed, give the data to my JSON data variable, and then you just log it. OK, I hope that made some sense. Tell me, guys, do you want me to explain more on async await? All right.
Just show us a demo.
So till now we are seeing only synchronous, right?
No, we have been using asynchronous almost since last week. See this?
No. On this example, on the promise I'm saying.
So all these examples are asynchronous programming. Like I said, asynchronous is something where you wait for something to happen.
Okay, then on terms of await also we are waiting something to happen, then only the next thing should go on, right?
Correct.
Then it should come under synchronous, right? I'm just asking.
No. So the best thing about async await is that it is asynchronous programming. OK, so let me write this. Async await. OK, now this is still asynchronous programming, but written in a synchronous manner. Meaning, as you just put the word await here. Okay, I put the word await here, and now to a human mind, this looks like a synchronous programming. Looks like synchronous programming. Okay, we are still waiting for this thing to happen. Only after that we are getting data here. We are still waiting for data.json to happen. Only after that we are getting JSON data here, and then we are logging it. We are still waiting for things to happen, but the way we are writing it is very, very clean now.
Okay.
All right. Now, one thing that I want to make sure you guys understand, because you'll be using it, is where it is. Yeah, you can only use await inside an async function. Okay, so for example, let me do this. Const abc, I am defining a function here, and I am saying await. I am just typing some function, do something. Okay, now you see a red colored error line here. It says await expressions are only allowed within async functions and at the top of level modules. Okay, I'll come to that this end part, but you can only use await inside async functions. What it means is you have to put async here. Okay, that's why the concept is called async await. It's not called await. Okay, so if you notice, wherever I have used await here, yeah, I'm also using async everywhere. Okay, you can't use await without an async. Understood?
But Saurav, on your previous example, we couldn't see a keyword async.
Correct. Very good.
Yeah.
Yes, yes, you're true. You're right. Now, let me remove this and let me get the error back. Now, you are seeing that in the previous example, you are not seeing any async written. You are just simply using await. Correct?
Yes, sir.
Okay, so now if I hover on this, so the async part is only the first part of this line. Okay, so see, await expressions are only allowed within async functions. That is what I told you. And at the top levels of modules, meaning since this JavaScript file is a module for me, right? I can use await directly within this module. Okay.
Yeah.
Although if this was in a function, for example, function ABCD, and then I would have written this, then yeah, it will fail. Okay, since these lines earlier were not inside a function, these were at top level of my JavaScript file. That's why I was able to use await directly. But if your await calls are inside a function somewhere, you have to put async.
Got it, sir.
Okay, not here. All right. So I don't know. Sorry, who asked about await keyword? Was it Pooja who asked await keyword?
Yeah, yes, it is me. I understood.
Okay, awesome. Any more questions? All right. So we were talking about database. Now you all should have understood by now that we initialize the DB with the config, and then what we are doing here, if you see again, whatever DB operations I am doing, okay, right now I am just checking if my DB has this table called heroes. Okay, even that operation is an async operation. Okay, so if you hover upon this, you will still see there is a promise here. Okay, a promise of a boolean. So if I put await in front of this function call, I am expecting a boolean, true or false. Correct? So I can simply use it in my if statement. So I'm saying if the table is not there, then you create that table. And the way to create a table is again db.schema.create table. This itself is again a async function. Okay, and you put await before that. I'm not assigning it to a value because I really don't care about that value. I just care that the table was created. So only after the table will be created, only after that, this console.log will be executed. Okay. Similarly, I am checking after creating or making sure that the table is there. I'm just checking if the initial list of heroes is there. So I'm fetching all the records from my table and just doing a check whether I have at least 4 heroes there. Okay, if I have at least 4 heroes, I'll print a statement saying that yeah, sure, everything is fine. Otherwise, I will insert the initial list of heroes which I had defined in my sample data, right? So this was my sample data. So I'm getting the sample data from this JavaScript file. I'm using that here. Okay, any questions about this? All right, cool. Now, then like I said earlier, I have defined some helper functions for me. Insert one record, insert multiple records, get all the records, get record by ID, update any record, delete any record. Okay, so all these helper functions are very simple. Insert is simply calling db.insert. Similarly, insert multiple records is also calling db.insert. The only difference is here the records variable will be an array. Here the record variable will be an object. Okay, this will be an array of objects. Get all records, I am simply passing the table name and using that table name, I'm getting all the records. Get record by ID, I'm passing the table name from which I have to get the record, and then I'm passing the ID. Okay, and then I'm simply building a simple SQL statement, get star from some table where ID is ID. Okay, update, I'm passing the table name which I want to update, and then the new record. Okay, the only constraint here will be I want to update a single record, so I have to pass an ID also, which should be a part of my new record object here. This new record will be an object. Okay, and it should have a key called or a property called ID. And then I'm just updating it. Delete also is the same thing. I'm just simply saying from which table where ID is equal to ID that I passed, delete that row. And done. Okay, so I have defined all these helper functions. And then what I have done is I have exported this. Since this is a module, right? This is an ECMAScript module. I can do this. Okay, export. I am exporting an object of all these functions. Okay, as soon as I am able to do that, I can use those here. Now see, I'm using my db.utils.js, the database JavaScript file that I created, right? Where I exported all these functions. So what I have done is I am importing these all functions from that file, from that module. Okay. And then I'm simply using those. So I've bound the /hero API with get all records. Okay. /hero by ID. I'm binding it to get record by ID like that. Okay. Create a new user or a hero. I'm doing some checks. I'm basically making sure that all my mandatory fields are there or not. If name, power, or full name is not there, I'm just simply returning a status 400 and saying name or power or full name property not found. Okay, if everything was there, I will simply insert a record. Whatever result I got, the new row number, I'm just sending it back. All right. Any questions with this, guys? Because this is uh, your basically a full stack application using Express. Okay, so what we have done, we have created 3-tier architecture. We have a UI5 frontend, we have a Express JS service layer backend, and then we have a SQLite database. Okay, let me show something to you here. Now, this is what you will do in mostly all your applications. When I'm writing SVC, I mean service, okay, service layer, and then your database. This is how your programs will work. Okay, everyone understands this 3-tier architecture? Guys?
Yeah, sir. Yes, sir.
All right, cool. So there are variations on this 3-tier architecture. As long as you understand the core concept of what a 3-tier architecture is, you will always understand the variations. Okay, so the variations can be the front end is written in UI5, the backend is written in Node.js, as our example is right now, and the database is your SQLite. Okay, so this is one variation. Then you can have another UI5, Node.js, HANA-DB. Okay, you can have another. You can so using the same 3-tier architecture, you can just replace any component here. Will still be using the 3-tier architecture. Now, everywhere I have used Node.js as my service layer. Instead of that, I can use, for example, what? Python or Java, right? So you can mix and match. And instead of having just one data source, okay, so what I can do is I can probably extend it. Wait. Okay, what I'm doing now is this. Okay, now maybe I'm getting some data from my database on Cloud Foundry, and some data I'm getting from ECC on-premise, and some data I'm getting from, as an example, I'm getting from S4HANA, which is cloud. So this is my DB on BTP CF. This is my ECC SAP ECC on-prem, and this is your SAP S4HANA cloud. You're still using the 3-tier architecture. Okay, let me write it. 3-tier architecture. You are still using the 3-tier architecture, which is basically your front end, your back end, and a data source. That data source itself can be a DB, an on-premise system, a cloud system, a third-party application, a third-party API, whatever. Doesn't matter. You are still within 3-tier architecture. Any questions here? Anyone?
SVC full form.
Okay, sorry. Let me write. This is your service layer. Service layer meaning the express REST APIs that you are creating, right? So this is your service layer. Okay. Now UI, when I'm writing UI, you can also have a mobile app for that matter, right? Instead of UI5, you can say that I want to create a Flutter UI mobile app and use that as my client side. Again, you are still within 3-tier architecture. Okay, so as long as you understand what 3-tier architecture is, and as long as you understand, all you need to do at the end is you should know how to create a UI, you should know how to create a service layer, and then you should know how that service layer talks to a database or some other system. As long as you do know these 3 or 4 things, you are all set. You can really tackle any project, any complex problem whatsoever. Okay, and for me personally, that gives me a very good amount of confidence. The first time that I understood this thing properly to its core, I think it was 2011, 2012. I had just started my career, and after that, I could make any sort of application. All right, any questions on 3-tier architecture?
Can you please share the project superhero with us? It will be helpful for us in order to practice. And as well
Definitely,
this
yeah.
PPT.
PPT I'll definitely share. At the end, I'll share all the slides. The reason I'm not sharing is because since we are talking, right, I'm creating more and more slides as I talk to you. Okay, so after the training, I'll share all these slides with you. Don't worry. But yeah, the
Yes, sure.
superhero project, I'll put it in my GitHub. I'll share you guys the link.
Yeah, sure.
All right, now, before I move on to the next thing, any questions on a 3-tier architecture, on the service layer, express application, DB connection, whatever? All right, now, so we are done with step number 3. Okay, done. Now comes your step number 4. Now, as I understand, all of you guys understand UI5, right? Is that a correct understanding?
Yes.
Awesome. So I'll not, like I said, I'll not spend time doing UI5 then. Okay, it's very easy. I just show you how to do one simple API call. Then you can take care of rest on your own. Now I am in my UI5 project. Okay, see, you will be familiar with this kind of a folder structure. Yeah, index, manifest, component, and then view, controller, model, and all that. So what I've done here is, and again, I'm very comfortable using fetch for my API calls. Okay, I used to do $.ajax a lot when I was doing UI5 some 5-6 years ago, but now I've moved on to better things. So I'm not using $.ajax anywhere. I know because for me, I know $.ajax is simply just calling my REST API, getting some data from there, right? Same thing I can do with fetch, and fetch is easier to write and understand. So it's totally up to you. If you want to use $.ajax, go ahead, please use $.ajax. Okay, it's not hard to use. It's just that too many lines of code. Okay. Yeah. Do you understand? There are too many lines of code. So I don't use $.ajax, but yeah, go ahead. Sure, you can use it. So I'll put this also in my GitHub repo so that you guys have a ready reference to the UI5 project, and then you can extend it as much as you can. Okay, so far I have just simply created a list of all the heroes and I am displaying that list, and there is some filter functionality also, right? But you can extend it till any point. Data here you'll get the JSON data. Okay. Yeah. Let me see what the next step is. No. Okay. One thing that I want to show you guys. Okay, it's very cool. Just want to show you that so that you understand the importance and you will never forget to use it in your own applications. I'm just missing my. Sorry. Let me do some. Okay, so where's my postman? Okay, get all heroes. And let me see response headers. Okay, now see this. The current size of my response is 876 bytes. Okay. Now, what I want to do is, so we are still seeing only how many? Let me close this. 1, 2, 3, 4, 5, and yeah, total 5 objects are being returned from my database. Total 5 heroes. Correct. Now consider that you have thousands of heroes. As you can imagine, your size of the response will increase. Okay. As well as the time that takes to load that response will also increase. Everyone understands this concept? Larger the size of response, longer it takes to load, first of all, transfer on network. It's very simple, right? It makes sense. It is mostly common sense, right? Anyone who is not able to understand this one?
Understandable, sir.
Awesome. Now, what we want to do is just a sec. No, it's not label. And I'll set it again. Yeah. Now, I want to show you guys something. Not there. Okay, that's all right. I want to show you something called compression. So there is a package called compression on npm. This compression package here is a middleware for your Express applications. Okay, what I can do is very simple. So for example, yeah, here. Now, what I'll do is simply use this compression function, and the effect it will have is that it will compress my response. Okay, normally like you do zip unzip on your laptops, right? You zip a file, it reduces the size. You unzip a file, it will then again make the size original, right? The same thing can happen over on your browser as well. Okay, so there are standard compression algorithms which browsers understand. Okay, so what I will do is I will do this. I will install compression first of all, npmi compression. Thank you. I'll go to index. I'll use import compression from compression. Okay, very good. And then I'll use compression app.use compression. Press your response sizes. Okay, done. Now I hope my server got restarted. Yeah, my server got restarted. Okay. Okay, let me just remove this. Okay, cool. How it impacted our this get call. Send. Okay, somehow. uh, just a sec. So okay. There are times when the compression has a negative impact, but I'll show you in a UI project. Just give me a sec. Okay. What I'm doing here is I'm putting my UI5 project inside my Node project. Okay. See, so I have my UI5 project now inside my Node project. So if I on my browser now, if I do simply localhost 8888, show me my UI5 project. Okay, since I am serving my static files from my public folder and my UI5 project has an index.html file, this works automatically. Okay, I really didn't have to do anything. Now, if I go there, refresh. Okay, let me see. Yeah, now you see the difference here. Since I'm using compression, right? Your size of the response now it is only 211 bytes. Actual resource size was 607 bytes, but the transfer was only 211 bytes. Why? Because I am compressing my response. And the way you notice that is you click on a call, right? You go to response headers here. Okay, sorry, not response headers, your request headers here, and you say accept encoding gzip. As soon as you say that, okay, your server will know, okay, the client can handle compressed response. Okay, and then it will send you the response in a compressed manner, which takes care of everything. Okay, now understand, if you are having MBs of data or GBs of data that you are trying to transfer over the network, if you don't do compression, then you will consume all that bandwidth from your user. Since we are all paying for internet, right? Everyone pays for internet, and however much data I use, I pay for that. Correct? So if you compress your responses, first, the data transferred over network will be lesser. Also, it will take lesser amount of time for your applications to load. So that's the power of compression. Compression you have to enable on your server side. Okay, any doubts about that? Anyone?
No, sir.
Okay.
We can also use concept like skip and count. Data is large. So even after compressing, I couldn't compress the data, means loading the first set and then the second set, third set. So like that also we can build our logic, right?
No, I
Or
sorry, I
else
didn't
it's
get
always
you.
better to compress.
There is some background noise coming from your side, I think. The phone or something. Can you come again, please? Hello? Okay, now another thing, just another example of compression. Okay, see this. So I am fetching SAP UI core.js file from my SDK, okay, directly from SAP servers. Now, notice the size here. Okay, if you hover on the size that was transferred over the network was 210 kilobytes, while the actual resource size, actual JS file size was 763 kilobyte. Right? That's more than 1/3 reduction on size. That means more than 1/3 reduction on the load time as well. Transfer time and load time. Okay, see this? Content download only 45.58 milliseconds. But if I did not use compression, okay, and the SAP server did not allow for compression, then see, then I will have to load all the 700 kilobytes. I will take time and all that. Okay, so wherever you are creating productive applications, okay, when you are doing applications for your clients, especially then, please use compression. Okay, and compression is not something which is specific to Node.js. NPM has simply given us a package for that, which is very easy to use. But compression is just basically a web concept, an HTTP concept. You can use that with any sort of language. Okay, Java, Python, PHP, whatever. All right, next. Okay, so let me go here. Okay, everyone understands what helmet is, right? Can anyone tell me what helmet does? No one? All right, cool. No worries. So helmet is again another package from NPM. Okay, let me install it first, then show you npmi helmet. Okay, so I'll show you what helmet is. Now, helmet helps you secure your Express applications by setting various HTTP headers. It's not a silver bullet, definitely yes, but it can help. Meaning it cannot safeguard your application from every kind of an attack, every kind of an hacking attack, but it will help. Okay, so the way you use that is again very simple, like every other middleware. This is why Express is very simple and easy to use. Okay, easy to understand. All you need to do is you just import some package from npm. If that is a middleware, you just simply use app.use and that middleware. Okay. Put helmet from helmet and you use app.use helmet and done. Okay. Now see the difference. I'll show you the difference. So far, notice the response headers. Okay, guys. The original response headers are these. Let me take a screenshot for later. Actually, let me close this. This is causing problem. Now, so these are the old response headers. Now I will simply refresh this page and then I'll show you the new response headers. Okay, refresh. Okay, sorry. Okay, wait. In reason it is saying CSP. But it's security. What is this? Social event. Content. I will have to do some changes. Sorry. So helmet gives me, or helmet adds one header called content security policy. Due to that, my UI5 app has stopped loading, but let's fix that actually. Okay, so this thing should have worked. This thing should have worked. Yeah. Now, notice the response headers now. Okay, so earlier there were only some 5-6 response headers, right? Now I'm getting a lot many. All those response headers, right? For example, your cross-origin embedded policy, your everything, okay? Your X content type options, no slip, all these are headed, all these are added by helmet. So I think we spoke about the clickjacking attack, right? So clickjacking is where you can click on certain buttons. A hacker can put an iframe on top of your site and ask the user to click somewhere, and they can hack the user session there. That is stopped by using this X-frame options, same origin. Okay, all these are added automatically by a helmet. You don't have to do anything on that. You just add a helmet and done. Okay, now the next thing that we will do is we will simply deploy this application on our BTP sub account. Okay, while I do that, any questions from anyone, guys? Anyone?
Oh, sir.
So what I'll do is I'll create a how to deploy some file on some project on BTP. We create a manifest.yml file. Okay, I'll do a simple copy of manifest. Put my name here actually so that. Okay, so just to reiterate on manifest.yml. So manifest.yml is my deployment descriptor. Okay, it's called a deployment descriptor. It describes my deployment. Okay, so there is a particular syntax to writing YML files. So this file starts with 3 dashes here, 3 hyphens. Then we write applications. Okay, so this thing tells me that I can deploy multiple applications at the same time. Okay, right now I am doing simple thing. I am just deploying one single application. Every application will start with a hyphen, and then you notice the spaces here. Okay, if I do this, it won't work. Okay, I have to put 2 spaces here. Okay, I give the name of my application. I say what kind of build pack I'm trying to use. Because it's a Node.js application, I'm using a Node.js build pack. I'm trying to use only 128 megabytes of memory. Disk quota is only 200 megabytes, which should be sufficient, I hope. Path is just dot, meaning all my files here, okay, all my project files, all the files required to run my project are in the same directory as manifest.yml. So that is what this path means. As an example, if I had all the files, for example, public, your db-utils.js, all the JS files, package.js and everything inside a folder called app, for example, here. Okay, so in this case, I have my manifest.yml outside a folder. Okay, all my Node.js files are inside the app folder. That's why the path says app. So it says to Cloud Foundry CLI that pick my project files from this particular folder. Okay, in our case, what we are just going to deploy, all my files are within the same folder. So I just put a dot here. Okay, any doubts with manifest.yml, guys?